The universe is an immense and mesmerizing realm. It glows with stars, galaxies, and nebulae. We are captivated by its beauty and its enigmas. However, this enchanting expanse also harbors dangers. Space is not a gentle environment. It poses threats to our planet, our technology, and our very existence. From wandering asteroids to intense solar flares, the cosmos commands our vigilance and respect. We must comprehend these threats to protect our future. For thousands of years, humans have looked at the stars and wondered about our place in the universe. We have achieved remarkable progress in space exploration. We have sent probes to distant planets and landed humans on the moon. But as we journey further into the cosmos, we must also be mindful of the dangers that lie ahead. The universe constantly reminds us of nature's power. It presents challenges that compel us to innovate and adapt. By studying these cosmic threats, we gain a deeper understanding of our place in the cosmos. In doing so, we not only ensure our survival, but also expand the frontiers of human knowledge and creativity. In 2004, astronomers made a startling discovery. They identified an asteroid that could potentially collide with Earth. This space rock, named Apophis after the Egyptian god of chaos, caused global concern. Early calculations indicated a disturbingly high chance of impact in 2029. The media quickly picked up the story, highlighting the potential for a global disaster. Apophis, at about 1,100 feet in diameter, is larger than the Eiffel Tower. Its impact would release energy equivalent to millions of atomic bombs. Experts predicted that a collision would have catastrophic effects. The impact would cause widespread devastation. The resulting dust and debris would likely trigger a global winter, severely affecting agriculture and ecosystems. The discovery of Apophis was a wake-up call for scientists. It underscored the need to monitor near-Earth objects and develop technologies to prevent potential impacts. As astronomers collected more data on Apophis's path, a wave of relief started to spread. New calculations, using fresh observations and improved models, showed a less threatening scenario. The likelihood of a 2029 impact decreased significantly. Scientists confirmed that Apophis would indeed come close to Earth on April 13, 2029. However, it would pass safely, about 19,000 miles above the Earth's surface. Although this is nearer than some satellites, it is far enough to avoid a collision. While the immediate danger has lessened, Apophis remains a subject of interest for astronomers. Its close approach in 2029 offers a rare chance for scientific study. Scientists aim to examine Apophis during its flyby, studying its composition, structure, and rotation. The story of Apophis highlights the importance of ongoing observation and scientific teamwork. Although Apophis is no longer an immediate concern, the universe still harbors other potential threats. One such threat is Bennu, an asteroid first identified in 1999. Bennu is classified as a rubble pile asteroid, which means it consists of a loose aggregation of rocks bound by gravity. It spans approximately 1,600 feet in diameter and has an estimated mass of 79 million tons. Bennu's orbit is particularly worrisome because it brings the asteroid close to Earth every 6 years. Researchers have identified several potential impact scenarios for Bennu between the years 2175 and 2199. While the likelihood of these impacts is relatively low, they cannot be dismissed. The potential impact of Bennu could be catastrophic. Its size and mass would result in a massive release of energy upon collision, leading to widespread destruction. Bennu's unique composition further complicates the potential impact scenario. To gain a deeper understanding of Bennu and evaluate its threat to Earth, NASA initiated the OSIRIS-REx mission in 2016. OSIRIS-REx, short for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer, was an ambitious mission aimed at meeting Bennu, examining it closely, and bringing back a sample of its surface material to Earth. This sample would offer crucial insights into the asteroid's makeup, history, and potential impact threat. After a 2-year voyage, OSIRIS-REx reached Bennu in December 2018. The spacecraft spent nearly 2 years orbiting Bennu, mapping its surface, analyzing its composition, and identifying a suitable site for sample collection. In October 2020, OSIRIS-REx executed a successful touch-and-go maneuver using its robotic arm to gather a sample from Bennu's surface. The spacecraft then embarked on its return journey to Earth, carrying its valuable cargo. The OSIRIS-REx mission represented a major achievement in planetary science and defense. The data and samples brought back from Bennu will provide scientists with extensive information about this potentially dangerous asteroid. While asteroids and comets are notable threats to Earth, the dangers from space extend beyond these celestial bodies. The Sun, our life-giving star, can also release powerful energy bursts that threaten our technology and astronauts. These eruptions, known as solar flares and coronal mass ejections, CMEs, highlight the Sun's formidable power and our susceptibility to its activity. Solar flares are sudden, intense bursts of radiation from the Sun's surface. They are often linked to sunspots, which are cooler, darker areas on the Sun's surface, associated with strong magnetic activity. CMEs, in contrast, are massive eruptions of solar plasma and magnetic fields that can travel at millions of miles per hour. Both solar flares and CMEs can significantly impact Earth. When a solar flare or CME reaches Earth, it interacts with our magnetic field and atmosphere, causing a geomagnetic storm. These storms can disrupt radio communications, GPS systems, and power grids. In October 2003, the Sun unleashed a series of intense solar flares and CMEs that struck Earth, causing widespread disruptions and highlighting our technological vulnerability to space weather. These events, now known as the Halloween storms, were among the most powerful geomagnetic storms ever recorded. They led to extensive radio blackouts, disrupted GPS navigation systems, and triggered auroras visible as far south as Florida and Texas. The Halloween storms significantly impacted various sectors, including aviation, communications, and power grids. Airlines had to reroute flights to avoid high-latitude regions where radiation levels were elevated. Radio communications were disrupted, affecting emergency services, military operations, and commercial shipping. Power grids experienced fluctuations and outages, underscoring the vulnerability of critical infrastructure to space weather events. The Halloween storm served as a wake-up call for governments and industries worldwide. They emphasized the importance of space weather forecasting and mitigation strategies to protect critical infrastructure and ensure the safety of astronauts and the general public. As we journey deeper into the universe and become more dependent on technology, understanding and mitigating cosmic threats becomes increasingly vital. NASA and other global space agencies are leading this charge, creating innovative technologies and strategies to shield our planet from the numerous threats in the vastness of space. From asteroid deflection missions to advanced space weather forecasting systems, we are becoming cosmic protectors, securing our future against the unknown. One of the most promising research areas is asteroid deflection. Scientists and engineers are investigating various methods to alter the trajectory of an asteroid headed towards Earth. These methods include kinetic impactors, which involve crashing a spacecraft into the asteroid to change its course; gravity tractors, which use the gravitational pull of a spacecraft to gradually move the asteroid; and even nuclear explosives, considered a last resort for deflecting large asteroids. Besides asteroid deflection, space weather forecasting is another critical focus area. NASA's Solar Dynamics Observatory, or SDO, launched in 2010, provides continuous observations of the Sun, tracking solar flares, CMEs, and other space weather events. These observations help scientists understand the Sun's behavior and improve the accuracy of space weather forecasts, giving us more time to prepare for and mitigate the impacts of solar storms. The quest to protect our planet from cosmic threats is an ongoing journey, requiring international collaboration, technological innovation, and a profound understanding of the universe we inhabit.